professional education and affiliated to the Dr. of APJ Abdul Kalam Technological University KUT and approved by All India Council of Technology Education AICTE, New Delhi. The college is owned and managed by the Malakam Orthodox Syrian Church, which has played the potential role in the institution and established and the operations. The institution is focused on often degree programming in the various engineering streams. In 2001, the college has started the functioning a new generation engineering college since its inception of 2001. The college has been on the steady path of growing and grown up upgradations. The Marbasium Christian College of Engineering and Technology has the scored NBA accreditation for this from the CE and EEE department and currently offering a BTech programming in CSE, AI, CE, CSE, ME, ECE, and engineering. I take this very professional time to introduce our today's speaker, MS Keerthana ma'am. He is an assistant professor with 5 years of experience in teaching and 1 year of experience in research in IUCA and LOGE Data Center, Pune. Her research area of interest in network security, blockchain, and machine learning algorithm. She is pursuing a PhD in Anna University in the area of secure in blockchain. She's working as an experience in high performance computing HTC Coronado in LIGO India project. She's currently writing my research in article in the network security and assisting the scientists in the analyzing the data site in the HT corner. Welcome you, ma'am.
Hi, good morning, everyone. And thank you, Arulmali, for a great introduction. Today, we are going to see about overview of machine learning and detailed session of supervised learning in the afternoon session. So in morning session, we are going to discuss about what is machine learning and what are the paradigms in machine learning and supervised, semi-supervised, unsupervised, and reinforcement learning in the categories of machine learning. So let me share my PPT first. Is my PPT is visible to all?
Yes, ma'am.
If it is, yeah, okay. Thank you. So first of all, what is machine learning? Actually, it is a subfield of artificial intelligence and deep learning. Second thing is deep learning, and it is a subfield of machine learning. So all these terms are coined from the artificial intelligence domain. It means that with the help of human, every system are going to react and give the output as a human in a fast way. So that is an artificial intelligence. It means that it will be dealing with many artificial agents. It doesn't it? It means computers in working in artificial manner similar to a human. What the human will answer, the artificial agents will do. So machine learning, it is an application of artificial intelligence that it provides a system the ability to automatically learn and improve from experience without being explicitly programmed. It means that in current scenario, ChatGPT is ruling the world. It means OpenAI, Google's Gemini is all ruling out the world. It means that you will be in a position of asking questions only. So these agents will be giving you the appropriate answers. It means 90% of accurate results of answers to you in order to save your time for coining by yourselves. So this machine learning is mainly focuses on development of computer programs. It means that at background the programs are done for accessing your data and use it as a prerequisite for themselves and will be providing you the results. So see here, one of the beautiful example, see this content. By seeing this, I'm I am very happy to tell you that I will be going out of country. Hope you got the message. I can able to learn this message correctly, but there are spelling mistakes over there. This is the way the machine learning works. If you give the wrong spellings to your agent also, it can able to understand what you are coming to tell to them. That's why they are trained in very frequent data sets. That's why they can able to learn what you are trying to say to that agent. This is the beautiful thing about the machine learning paradigms. So, as I already said, artificial intelligence, this is a technique that enables the computers to react as a human with intelligence. So, next thing is machine learning. So, machine learning, it is a subset of AI. It uses some algorithms. So, to act as a human intelligence, and subset of ML is a deep learning. It is also using the algorithms that permit the software to train. It means all these things, that is AI and machine learning and deep learning, you want to train that model for giving the appropriate answer. It means that now the ChatGPT are developed by asking frequent of questions. Suppose you are asking a question like what is machine learning to your agent, means you want to train that agent by asking the same question in a different manner. That's why the agent will be getting trained. If you ask the question with the spelling mistakes also, it can be able to understand. So the next thing is here, big data. So big data and data mining, it is a subset or acting as a subset of these three domains. It means that by using these algorithms, by keeping the data sets, you are processing those data and giving the related output by using these algorithms. So these algorithms of under the domain of machine learning, deep learning, and AI, it will be playing a crucial role in processing the data. So these algorithms present in it will be acting as a main role in the big data domain and data analytics also. So why you are going for an ML? So the first thing is automation and efficiency. Automation and efficiency means it will um, be giving you the automatic results and in an efficient manner. So the second thing is data driven decision making. So data driven decision making means by getting the insights from the data sets in the domains like businesses or scientific organizations in processing the data, and you will be giving a step by step solving method. So that is data driven decision making. So the third thing is personalization. Personalization means it is playing a role in predictive powers. It means that these ML models can forecast the trends, and it enabling the applications in areas such as share markets or weather forecasting or analyzing the data in the scientific fields. They are incorporating their stand in that area and giving you the better results. So that's why the term personalization is coined. So the fourth thing is improving cybersecurity. The term cybersecurity is mainly dealing with security standards, that is in military areas. In order to provide secrecy for their data, some algorithms are needed. So those algorithms are coined from the machine learning for improving their status of their data. So the in fifth one, healthcare innovations. In healthcare innovations, ML is used in diagnosing the major diseases, that is cancers or uh, cancers or any blood diseases, diabetic diseases. In these diseases, or predictive analysis is mainly done in the healthcare innovations. In that case, this ML is playing the crucial role. So the sixth thing is real-time analytics and forecasting. Real-time analytics means it is playing a role in weather forecasting. That's why real-time analytics. And in agricultural field, also this ML is enabling the precision farming or health monitoring of the crops or a predictive analysis of yieldings like that. They are doing real-time analytics. So the last before thing is fraud detection. So fraud detection and prevention. Here these ML models can detect the patterns associated with the fraudulent actions are going to done, and they will be providing a real-time fraud detection or real-time fraud prevention in share markets or financial analysis and in military applications like that. So the last and best thing is adaptive systems in all the fields according to the solutions or provider. The ML will be adapted easily for according to the fields we are doing and playing with ML algorithms. So how it works? So the first thing, you are working with the ML, you want to input the data. So the first thing, you have to input the data, and the second thing, you have to analyze the data. What kind of data you have taken, whether it is a data sets or image data or video data. You for the things you have to analyze the data. So the third thing, you have to find the patterns, in which pattern the data sets are designed or coined. So, so the next thing is you have to do the prediction, that is predictive analysis. So in weather forecasting, they will be predict whether it will rain today or not. So for example, I'm saying that. So that prediction is doing here, and after the prediction, you will be storing the feedbacks according to the predictive analysis done on the data. So by this way, the ML algorithm is going to work. So machine learning applications, there are varieties of applications of machine learning are there in retail, that is supermarkets, and in traveling, in passport offices, in analyzing the travel of a persons, and in healthcare, analyzing our predictive analysis of the diseases, and in finance, secured transactions between the sender and receiver like that, and in medias also, YouTube's or movie industries. In everything, these ML algorithms are playing a crucial role. So see here, this is a beautiful example. Autonomous car technologies in foreigns and in our smart cities also, it has been implemented. So in Chennai or Bangalore, if the car is going beyond the speed limit, it will be automatically detected and it will be caught in another subsequent station by the traffic polices. So they will be going to analyze the speed of the car by having fixing the cameras in check post like that. So this is autonomous car technologies. And also in foreign, without the driver, the car is driving by analyzing. It means that consider these are the cars with the autonomous driving. It will be predicting the speed of the previous car, and the car is coming behind, and it will be regulating its speed. So without the driver, a car can able to drive by using the artificial intelligence, that is machine learning algorithms. So if the car is coming to hit with you, an alarm will be generated for the autonomous car technologies. This is a beautiful example of machine learning by in present. So the second thing is how the autonomous vehicles is working. So here in all the algorithms are implemented inside the car's software, and OS is developed for each and every cars. And RoboQ is a beautiful company who are designing this autonomous technology for Tata Motors and BMWs like that. So they are one of the example is Udacity is a one of the major platform for controlling your car by autonomous or in the training mode. So for that, each and every car is trained in the real time, and after that only they are implemented this. It means that in order to increase the safety and trust of those autonomous vehicles, they are training more and more. So these are the paradigms of the machine learning. So generally, machine learning is divided into three: supervised, unsupervised, and reinforcement learning. So supervised learning or generally is for predicting what will be going next. That like, and unsupervised, it will be dealing with the classification algorithms, and reinforcement learning, it will be learning from mistakes done with the previous learnings. So first, the supervised learning is it usually learn from the labeled data, and the output will be known after the training process is done. So, for example, if you consider the algorithms like decision tree algorithm or support vector machines algorithm or neural networks, these categories will be coming under the supervised learning. So, unsupervised learning, when it is the opposite of the supervised learning. Unsupervised learning is usually dealing with the unlabeled data. So data will be unlabeled, and the task here is to identify the patterns and group accordingly. It means that it will classify the data sets, and it will be giving you like the group 1, group 2, group 3, like that. And reinforcement learning. And another one thing is also there, semi-supervised learning. Semi-supervised learning, it combines the amount of labeled data and unlabeled data. It means that it is a combination of working of supervised and also the unsupervised learning. It means this semi-supervised learning is generally time consuming because it is a combination of previous those two algorithms. That's why it is a time consuming process. So the last thing is reinforcement learning. It will be abbreviated as oral, and here in reinforcements, the artificial agents will learn from the mistakes. It means that by learning from the mistakes happened in previous learning, it will be making their own decision by interacting with the environment. For example, reinforcement learning, the beautiful example is swiping robot. Now has a robot has been emerged for cleaning the house. First, it initially will read all the points inside the house, and after that only it will be starting cleaning, and it will be practiced day by day, and within 1 or 2 days it will be becoming pro in cleaning within the same house. If you are taking that robot and placing it in another house, again it will be starting from the first. It will be observing the environment, and it will start its learning, and it will again work. So that is reinforcement learning example. It is also known as a Q learning. See here in depth. Machine learning algorithms in supervised learning. What are the algorithms are included as classification. So in classification, it is made playing a main role in fraud detection, image classifications, and customer retention and diagnosis in the healthcare. That is disease diagnosis and regression algorithms. So regression will be dealing with the weather forecasting, that is predictive analysis. In regression, there are many types: linear regression, logistic regression, like that, or in any estimating the life expectancy or market forecasting in share markets or regularity predictions, like that supervised algorithm works. So whether unsupervised algorithm will be dealing with the dimensionality reduction and clustering. It means that it will be creating the clusters by considering the unlabeled data. The examples are structural discoveries. It means that Wikipedia is one of the major example for unsupervised algorithms, or it will be dealing with the big data or future extraction algorithms in in classic image feature extractions or pre-processing of the data. These kinds are dealing with unsupervised algorithms. So whether reinforcement learning, so reinforcement learning is mainly in game AI and chat GPTs and skill acoustics, mainly the robots, robot navigation. These are coming under the reinforcement learning. So these are the applications of the machine learning in facial recognitions or fingerprint missions or image recognitions, autonomous drivings, optical character recognition. It means that by a speech, if you are telling something and it can able to grasp your language and it has to convert into a text or video like that. That is optical character recognition and speech recognitions and in healthcare and diagnosis of diseases. So these are the major applications of machine learning. So here, in supervised learning, as I already said, it is dealing with the labeled data. Here you are going to train with the inputs and giving the output pairs. So the main goal is to learn from the mapping function. So the mapping function is used for the supervised learnings. So here there are technical mathematical functions are used here. So linear regression, classifications, or logistic regression models like that. So this is an example for a supervised algorithms. So first, I have to input some raw data. My goal is to find whether it is a tomato or not. Okay, so I'm giving the input raw data with some pictures, different pictures of tomatoes, and it will be giving into the algorithm and it will getting processing, and the model is trained by giving different pictures of tomato. So after the model is trained, my model will able to predict, yes, this is the picture of tomato. So this is the simple example of a supervised algorithm works. So for in this case, you have to train the model for getting the appropriate output for your input. So how the supervised algorithm works? So there are two phases are there. So first thing is training phase and second thing is prediction phase. In training phase, you are giving the input data and labels or figures. Input data can be a figure or a data set, anything can be. So the next thing, you have to adjust the parameters in order to minimize the errors between its predictions. If it is error is occurring, for that you have to input some algorithms for error minimization.
എനിക്കതാണ് കല്യാണം ആയാലും പഠിക്കൂലല്ലോ എന്ന് പറയും. കല്യാണം ആയതുകൊണ്ട് പഠിക്കൂലല്ലോ എന്നറിയില്ലേ. വീട്ടിൽ കല്യാണം ആയാലും ഇപ്പൊ എനക്ക് അടുത്താഴ്ച വെച്ചാലും പഠിക്കാറൊന്നും കഴിയൂലല്ലോ.
Okay, so the second thing is prediction phase. So once the model is trained, in the above picture you have seen, once the model is trained, it able to give the correct output for your input, right? So after the prediction phase, that is training phase, is also known as a.
ഈ ക്ലാസ് എടുക്കുന്നതിന് നല്ലതായിട്ട് ഇത് കേട്ടോ കേട്ടാ. എനിക്കൊന്ന് ബിടെക് ചെയ്യാൻ തോന്നുന്നു.
In prediction phase, the model is able to predict. That is, training phase is also known as a prediction phase. So the first thing in training phase, you have to collect the data from the various, that is, input output pairs is also known as the data collection. So the second thing is, you have to, here I have said that internal parameters to minimize the error, right? So for that, you have to pre-process your data, that is cleaning, normalizing and scaling, or coding like that. You have to minimize the errors. For cleaning means removing the noise. So what are the types of noises available, we are going to see in the afternoon session, and how to handle the missing values. If any missing values present in your data, how to handle it. For that, separate algorithms are there, and for addressing their wrong inputs. For addressing the wrong inputs, also some algorithms are there. So these will be dealing in the training phase. So the prediction, next thing you have to choose which algorithm is appropriate for your processing input you have to use, whether it is a classification or a regression. Since in supervised algorithms, there are two things are available. One is a classification and regression. You have to choose which is suitable for our input, whether it is a classification or a regression, like that. Next thing, you have to train the model that will be doing in the prediction space. After that, you have to check the optimization of your algorithm, how optimizedly your algorithm is working, that is cost efficiency, time efficiency, like that. For that, if the efficient is less, you have to adjust your minimization of your loss. And after that, in order to achieve the high optimization, you have to adjust your loss minimizing. So then next thing, you have to evaluate the model. After that, after evaluation, you have to tune your model and making the predictions. So what are the types of supervised algorithm? There are mainly two types. One is a classification and another one is a regression. So first one is classification. So in classification, the output while dealing with the categorical data. So categorical data or categorical labels or classes, you will be going for a classification. So that, for example, if you want to detect the spam filtering, that is in emails, the spam emails will automatically filtered. That is a supervised algorithm. So it will be coming under classification. Or image recognition. By recognizing the image, whether you are inputting the animal's image, you have to find out whether it is a cat or a dog. So that is a classification algorithms. So the third thing is sentiment analysis. And in sentiment analysis, you will be dealing with the positive or negative entries, like that. So the second thing is a regression algorithm. In a regression algorithm, whether your output should be a continuous, it means that you are predicting some share market is will be high or low today, like that, predicting whether it will rain it or not, like that. In case of predictions, you will be going for a regressions. There are types of regressions are there: linear regressions, polynomial regressions, ridge regressions, and k nearest algorithm, that is KNN classic regression algorithms, SVMs, decision tree makings, and names bias. These are the algorithms will be coming under the regressions model. See here, for example, while dealing with the data science in processing the data, I have to plot a bar charts or like this. So this is known as exploratory data analysis in a data science. While dealing with this, I have to represent it is a logistic regression, means regression curve is this. If it is a linear regression, it will be like this, and it is also known as naive bias. It will be predicting the threshold, that is a plus or minus, like this. So minus values will be clustered here and plus values will be clustered here. Whether it is in case of decision tree making algorithm, it will be coming like if else case, that is if yes or else no, like this. And in a random forest, it will be dealing with the multiple decision trees, that is known as a random forest. Whether it is a linear regression, it will be coming with the support vector missions. And k nearest neighbor means it will be calculating the neighbors, that is possible points between that plus and minus entries, and it will be filtered and it will be given in the k nearest. Next, in Nave's bias, it will be dealing with purely probabilities, that is probability of getting error and non-probability of getting error. So purely it is majorly dealing with the probabilities. While in confusion matrix, it will be dealing with true positive or true negative and false positive and false negative. These are the confusion matrix is also one of the regression model in predictive analysis, and this is also Ornstein is also one of the algorithm. This confusion matrix is represented in a graph in ROC and AUCs. So see here in classification and decision tree. So this is an example. For consider, should I accept a new job offer or not? If it is yes, I have to consider my salary. You will be having thought of own salary. So for that, I have to take my decision whether it is yes or no. If it is yes, I have to communicate more than 1 hour, and they are offering some packages. I have to go on my positiveness on one side and also negativeness. For each and every positive, that must be a negative. Okay, so like that way I have to derive my decisions based on a tree basis. Each yeah, in real time, each tree will be having a branches. Like that, in decision trees also will be having the branches for accepting and declining my offer. I have to take some decisions and I have to uh, answer my questionnaires with some prerequisites. So these are the classifications of algorithm. First thing is a logistic regression and Naive Bayes and decision tree. So consider the examples of ice creams. I have a cone ice cream and cup ice cream and stick ice creams, and how the logistic regression and Naive Bayes and decision tree works. So the first thing in logistic regression, while taking a support vector measure as an algorithm, it will be having gathering all the input data and it will be processing with each and every data separately. So whether it is a news bias, it that is random forest algorithm, it will be constructing as a neural network. That is, this is one neural network, and this is one neural, and this is one neuron. So these neural networks are derived based on human brain's neural network structure. So Naive Bayes is one of the beautiful algorithms. If you people are doing some researches in classification or regression, you can go for a Naive Bayes. And while decision tree, it will be dealing with first. It will be taking some data sets, and it will be whether it is. It will be dealing whether it is a phone eyes or a cup eyes or a stick eyes. If it is a phone eyes, say yes. If it is not a phone eyes, say no. Like that, it will be deriving the decision tree and it will be grouping separately. So in conclusion, there are presence of 4 stick eyes and 2 cup eyes and 3 cone eyes. So like this, the KNN algorithm will be working on. So these are the types of regression algorithms. So the first one is a linear regression, and second second thing is logistic, and third one is polynomial regression, and stepwise regression, lasso regression, elastic fit regression. The first thing is linear regression. So for if you want to create a relationship between the input and output, you can go for the linear regression models. So it means that if you are assuming the straight line, this will be a linear regressions. So next, multiple linear regression is also there. It means that you will be getting multiple straight lines while analyzing your data outputs. So logistic regression will be like this. This is a logistic regression. So it means it will be classifying the minus and plus values with the curve. So the third thing is polynomial regression. It means if you want to, if your model wants to create a non-linear relationship between the input and independent and dependent data, you will be dealing with the polynomial regressions. So the next thing is stepwise regression. Stepwise regression is also similar to a polynomial regressions. And next thing is a ridge regression. In ridge regression, if you want to address the 2 categories, one is a overfitting and another one is a underfitting. If you want to deal with these 2 kinds of data, you will be going for the ridge regression. It means that if you want to regularize your machine learning model, you can go for a ridge regression. It means that it minimizes the sum of squared errors with some penalties. If the error occurs, you will be paying the penalty and you will be recovering those penalties. And next thing is a lasso regression. It is also similar to a ridge regression. It means that feature extraction kind of process will be taking place in lasso regression models. Next one is elastic net regression. It is a combination of a ridge. It is a combination of a ridge and lasso regression. It means that if it occurs, you will be paying some penalties and you will be recovering that, and you will be dealing with feature extraction process also in parallelly. So these are the types of regression models available in the machine learning algorithms. So as I already said, if your data sets will be filtered like this, it is linear regression. If it is filtering like a curve, this will be your logistic regressions. So regression model output will be like this. By in classification, we will be classifying, for example, if you want to classify the ice creams, you can go for a classification. If you want to predict whether the ice cream is present or not, like that you can go for a regression models. Next thing, we are going to deal with the examples of supervised algorithms. So the first thing is cybersecurity. In cybersecurity, consider there is a spam detection, like these kinds of mechanisms will be taking place. So that is a cybersecurity. For what are the algorithms you can use for cybersecurity means uh, leaves bias and SVM, that is support vector machine, like that you can use. And in healthcare, it will be purely dealing with the image classification. Here you can use CNN and SVM. And in finance, it is also doing dealing with that is uh, that is credit scoring type of things. You can go for a logistic regression model or a decision trees or a gradient boosting like this. And e-commerce is also dealing with share markets. It is also coming under credit scoring category. You can also use a logistic regression, decision trees, or gradient boosting, those kinds. So the next thing is voice recognitions. Here the algorithms used is NLP, that is natural language processing algorithms are used here. In this, you can use hidden morpho models, HMM, or recurrent neural networks models, or deep learning neural networks, that is DNN. These are the things you can do for voice recognitions. It means that in, for example, in media, they are tuning the voices of the singers, or that they are dealing with voice recognitions. So these are the advantage of the supervised algorithms. Um, Accurate and reliable. The second thing is easy to understand, and third one is good performance. So while dealing with the machine learning algorithms, it is well defined problems with the labeled data. Since supervised algorithms are dealing with the labeled data, if you want to process any labeled data, it will be giving you the accurate results, and it is very easy to understand, and this also gives you the good performance. What are the challenges while using the supervised algorithms? The first problem is, if you are giving the large amount of labeled data, it will be tedious in processing those large amount of labeled data, and it will be expensive and time consuming, and it will not recover the problems if it is overfitting problems or underfitting problems occurs. These supervised algorithms will not recover that. While we are taking any complex data, so algorithms is not suitable, and there will be a limited adaptability in supervised algorithms. If you are uh, inputting some unpredictable scenario, kind of unpredictable inputs, um, like weather forecasting data like that, it is very difficult to predict. So the supervised algorithms is not suitable for weather forecasting. If you want weather forecasting to be very efficient, you can go for unsupervised algorithms. So now we are going to see what is an unsupervised algorithms. So unsupervised algorithms is a type of a machine learning algorithm. While you are dealing with the unlabeled data, you can go for a unsupervised algorithms. This means unsupervised algorithm will be receiving the input data from the users without any correspondence to the output labels, or it must have some predictable structures or patterns or groupings of its input data by its own. It means that if I'm entering a message in a wrong spelling mistake, it should have the ability of reading that wrong data and giving you the correct output. So that is structure of an unsupervised algorithm. So what are the key characteristics of the unsupervised algorithm? The first thing is no labels. There is no labels of input data as like supervised algorithms. In supervised algorithms, you have to input with the labeled data, while in unsupervised algorithm, there is no need of labeling part. So the second thing is pattern discoveries. Here, these unsupervised models are specially used to identify what type of patterns are available or at clusters. Since unsupervised algorithm are purely dealing with the cluster algorithms, um, that is clusters. So, or any relationship within the input data. So, like that, the unsupervised algorithm is learning or data visualizations. You will be visualizing the data for easy understanding. So that is coming under the unsupervised algorithms. So for example, consider this is my input raw data. So here I have unlabeled data. That is no unlabeled. Since I don't know, it means that your system doesn't know what this orange is trying to say and blue points are trying to say or green points are trying to say. So these uh, data are giving into the algorithm. First, the algorithm will do the interpretation. It means that whether the data is known or not. What are the data are known and what are the data are unknown. Like that, it will be going to predict. So after the algorithm, after pre-processing, it will be giving you the data like grouping. It means that clustering of orange data and clustering of green data and clustering of blue points. It will be giving you like this inputs, outputs from with your input. So this is a thing of basic working of unsupervised algorithm. So see here, I'm having the picture containing the dogs, cats. So this is my input raw data. I did not say this is a dog or this is a cat. I did not say to my model. After completing the interpretation and pre-processing, my output will be these are the dogs and these are the cats. As my model is well trained to find out whether it is a dog or a cat. If it is a dog, group it, or if it is a cat, group it. So this is a working of unsupervised algorithms. So how it works? How it works means it will be looking for the underlying patterns or hidden structures present in your input or not. So after finding the hidden structures, it will group your data or it will cluster your data, and it will giving you the exact output. It means here the dimensionality reduction takes place. This is also one of the types of unsupervised algorithm, that is dimensionality reduction. So major two types of unsupervised algorithm. The first one is clustering and second one is association. Clustering means here you are creating a cluster of dogs and cluster of cats. So that is clustering. And association means it will be discovering the relationship between the variables that you are giving as an input. So that is association. It purely doing the interpretations of the input. So the first one is clustering. Clustering is also known as a grouping. That is, the data input points are grouped together and it is presented in the output like this is one group one and this is to group and this is to group three, like that. So what are the types of clustering algorithm is K means clustering or hierarchical clustering, density based spatial clustering, that is DB scan, uh, and agglomerative clustering. These are the types of clustering algorithms in unsupervised algorithm. What is an example is if you want to segment the cats or dogs in separate groups, that is one of the example of the clustering. So first thing is K-means clustering. So K-means clustering means that will be a centroid concepts playing a role here. It means that it will be finding the distance between each point and the centroid point is assigned as a cluster. So what are the steps in this algorithm? The first step is to initialize the K centroids randomly. After that, you have to assign each data point to the closest, that is nearer to the centroids. So after that, you want to update each centroid as a mean of these assigned points, and you have to repeat the steps until you are getting a prescribed output. So the objective functions of these k-means clustering is this one. Here, this is a centroid point, and this is a set of points in the cluster. This I is a set of points in the cluster. Next one is param clustering. That is partitioning around mediots clustering, K mediots. It is a sub-derived from the K-means clustering. It means instead of centroids, it will be dealing with the actual data points here. So the second thing is association. Here, association means I have already said you are identifying the relationship between the variables. For example, if you are doing any market-based analysis, that is in share markets, a customer is likely to buy a product or dislikely to buy a product. In Amazon's, if you are searching for related type of products, then you will be getting that product ad in your any social medias. So that is association. What are the algorithms present in association as Eckland algorithm, a priori, or FP growth algorithm? So the third thing is, next one is what are the examples of unsupervised learning means? First one is anomaly detections. In security based, if any fraudulent is likely to occur or not, that is anomaly detection. Anomaly detection playing a major role in financial transactions or fraud detections like that. um, the second thing was recommender systems. In recommender systems, if you want to discover the patterns according to the user satisfaction level, you want to suggest that item is present or not. That is recommender systems. And third thing is customer segmentations. If you want to group a customer based on purchase, it means that one customer will be purchasing this month for 1,000 or another customer will be purchasing for thousands. If you want to group the customers based on their purchases, so that is customer segmentation. So the fourth one is image compression. You have overcome the compressing of images in order to decrease your size. In Microsoft Paint also this option is available. So that is based on ML algorithms only. So the last thing is genetic data analysis. In healthcare, based on the genetic data, they can able to say whether the person can get a diabetic or not. So that is purely based on ML algorithms. What are the advantages of the unsupervised means? It will be uncovering the hidden patterns, but this cannot be done using the supervised algorithms. And what is Disadvantages, you can say it is little complex than supervised algorithms. So that is a disadvantage of unsupervised algorithms. So the third thing is reinforcement learning. So in reinforcement learning, it is also a type of machine learning. Here, the artificial agents and environment are playing the crucial role. It means that where the agent is learned to make the decisions by performing some actions. It means that that agent is already trained, well trained. Accordingly, it will be giving you the exact results. Here, what are the key concepts is first one is an agent. Agent, it is a decision maker or a learner that interact with the environment. So environment, the second thing, environment, it is an external system or a scenario based that agents wants to interact with. So the third thing is actions. What kind of actions are going to performed by an agent within that state? Okay. A state, it is a representation of the environment within the particular time, and reward is a feedback signal from the environment in response to an action. Accordingly, with these key components, the cumulative reward is calculated like this, where gamma is a discount factor and Q learning is one of the reinforcement learning. Here the function is represented as this function is derived by the Bellman. So here function, it means it will tells the agent the value of taking a particular action in a given state or not. It means it will be combining the intermediate reward and also with the discount factor reward. This is a Bellman equation for Q learning. So, how the reinforcement learning works? Here, you want to train a model. So, suppose I'm giving an apple image. Um, by giving the apple image, first my model is saying that it's a mango. Then it will be collecting the feedback from the environment. Um, whether my answer is correct or not. If there are a majority of a wrong, if that feedbacks will be noted, and after that it will be going to predict with the next one, it will be giving you the output that is an apple. So based on the feedback from the customers in the environment, this reinforcement learning will be working. So that is based on, in simple words, we can say that trial and error basis. So the agent takes the actions, that is feedbacks from the environment, and receives the feedbacks and learns according to the actions, and it will be putting it output. So there are two kinds of behaviors are there. One is exploration and exploitation. Exploration means it will be learning new from having the feedback, and exploitation means leveraging the knowing the actions that is yielding the highest rewards. That is exploitation. So this is a machine learning and deep learning. What are the difference between the machine learning and deep learning is, so machine learning, it will process the data and feature extraction, pre-processing and classification in separate stages. But in deep learning, all together will be done in a single stage. So by comparing with the optimization, deep learning is more optimized than machine learning and it is very fast. So these are the three comparisons of the artificial intelligence, machine learning, and deep learning. So artificial intelligence originated in 1950s, and after that machine learning has evolved, and after that deep learning has evolved. This deep learning is purely based on the neural networks, that is how the human brain is working. That will be taken as a base concept, and the neural network algorithms are derived, and by having that, the deep learning algorithm will be working. So the last thing is semi-supervised algorithms. So this is also a paradigm of the machine learning algorithm. It means it is a combination of the supervised and unsupervised algorithm. So this paradigm will be combining the small amount of labeled data and with a large amount of unlabeled data. It means that it also to ensure that if the system is having the unlabeled data more, how the system is efficiently working, that has to be your output. It means that the goal is to leverage a small amount of labeled data to make that model with the better representations and will be giving the more accurate predictions with the unlabeled data. It is very expensive and time consuming model. Why we are going for a semi-supervised learning means it is a cost effective labeling. It means if you are giving the labeled data and also the unlabeled data, it can be able to predict that input and giving you the appropriate output. And next one is improved performance. Whether the performance is low in supervised and unsupervised, it is overcome by the semi-supervised by giving you the better performance. And it will easily adaptable to the real time. For example, if you are considering the many real world data sets that are unbalanced means in terms of the you are having a labeled plus unlabeled. By making easy predictions, it will be becoming the more practical clarifications given by the semi-supervised algorithms. So how it works means you will be training the labeled data and you will be training the unlabeled data. By having these feedbacks from the labeled and unlabeled, you will be utilizing more amount of unlabeled data and you will be creating and training a model and you will be giving your output. What are the motivations by considering the semi-supervised semi-supervised algorithm means in dealing with the NLPs, that is, one person will be speaking English with one pronunciation, another person will be pronouncing the same word in another pronunciation. So the system has to understand if a person pronunciation is wrong, also the system has to understand. So that is natural language processing. And after that, by understanding that speech, it has to convert to a video or a text that has to be done at the final. So that is natural language processing. So bioinformatics or in a computer vision or AR, VR, augmented reality and virtual reality. So in these things, these semi-supervised algorithms are playing a major role. So see here, I'm having these input data and these are unlabeled data. These are labeled data, right? My model has to predict out of my goal is to find whether whether it is an apple or not. So the by machine learning level, it will be in unlabeled data only. I'm having my apple pick. So after processing the labeled data, it has to deal with the unlabeled data. So yes, the apple is present and it will predict that it is that apple present here. So this is the semi-supervised algorithm. So what are the approaches here is there are two types of training here. One is a self-training and then one is a co-training. So what is a self-training means? The model is to first train on the labeled data, that is a self-training, and it will be making the predictions on the unlabeled data, that is a second thing. These process done, the most confident predictions only will be giving you the output. So the second thing is co-training. So here in co-training, the labeled and unlabeled data, that is two separate models, are trained in a different perspectives. And after that, the subsets or futures of data will be given, and each model data from the other one will be correlated, and after that, your output will be predicted. So in self-training, NLP is considered like a text classification or information extraction or feature extraction like that in self-training. While dealing with a co-training, If you want to classify the web pages, that will be done using the code training. And another approaches is also there. Consistency regulations and graph-based methods and generative models, that is prompt-based engineering. That is prompt-based artificial intelligence is also based on semi-supervised algorithm of the GAN networks. That is variational autoencoders, that is VAE networks. That is ChatGPT is one of the best example for semi-supervised algorithms. uh, Self-training I have explained. And what is an algorithm of a self-training is, first thing you have to train a model with the labeled data. Second thing, you have to process with the unlabeled data. That is prediction, application of a prediction on unlabeled data. So the third thing, you will be adding the high confident predictions only. And you will be retraining the model again and again in order to get a um, appropriate output. This is self-training. So what are the limitations present here is the output from the input labels may be inaccurate. So the second thing is co-training. So co-training model, what is an algorithm is, you will be having two different features on the two different perspectives. Consider those two V1 and V2. You will be training those models separately. So after separately trained model, each model will be uh, predicted, and unlabeled data will be predicted separate, and labeled data will be predicted separate. Among these two predictions, which will be the confident fraction that will be taken according to your output. And you will be retraining the models iteratively in order to get the accurate output results. So what are the limitations here? So these two models are processing separately, right? So that will be might be becoming the disadvantage of this co-training model. So these are the types of semi-supervised. Now you are having the labeled data in one side and unlabeled data in one side. So this will be processed separately, and it will be applied into a k-means clustering as an input. And after that, this one, and when the classification is done and then prediction is done, and you'll be getting your output. This is one of the co-training model. So, by having a summary of the machine learning, we have discussed about four types of algorithms. One is unsupervised, supervised, semi-supervised reinforcements. Reinforcements is purely dealing with the robots, and semi-supervised is a combination of a supervised and unsupervised. Unsupervised algorithms will be dealing with the linear and linear regressions or logistic regressions, and unsupervised model is dealing with the clusterings or classifications. And these are the types. It is a chart of the types of algorithms present in the supervised, unsupervised, semi-supervised, and reinforcement learnings. You can take a look on this. And these are the applications of each algorithms. Lastly, I have put a chart of applications of these algorithms. And this is also another chart for these three types of learnings in machine learnings. And these are the key characteristics of the clustering type, and what type of cluster it can deal with. That is also I have represented. These are the summaries of topics discussed. You can go through these. And hierarchical agglomerative clustering, I have deal with one project in music classification. We have worked this hierarchical agglomerative clustering as giving the accurate results. If you are doing a research in clustering of data, you can go for hierarchical agglomerative co-clusterings. And thank you for wonderful opportunity given by Pencil Bits for sharing my knowledge about machine learning overviews. And in afternoon session, we will be dealing widely about supervised algorithms and what are the vision spaces and hypothesis classes are dealing with the afternoon session. And any doubts you can clarify. You can unmute your mic and ask, or you can ask it in your chat box. Arulmari. ResNet ML algorithm. Actually, it is a deep learning architecture. It is not an ML algorithm. ResNet, that is residual network. It is a deep learning architecture. Um, it will be dealing with visual recognitions. That is dealing with image recognitions, or if you are processing any medical images, this ResNet algorithm is useful. There are many versions are available in ResNet. You can check with those. Yes, you can use ResNet for predictive analysis. For example, if you're considering any image classifications that is using ResNet algorithm means you can predict. That is, if you are, for example, I have shown in my slide for predicting cats and dogs separately. For that prediction, you can use a ResNet algorithm also. Like CNN or CNN it is similar to those or CNN algorithms and algorithms. Any other doubts?
Madam, one doubt is so
Yes,
hidden.
sir.
Yeah, regarding hidden Markov model, you were saying about hidden Markov model, right?
Yes.
So how far it is usable for means the computation point of view, hidden Markov model, since there are so many probabilistic methods that are coming, right? It's like transition metrics, emission metrics, similar, so many metrics are coming into picture. So computation point of view, do you suggest that the hidden Markov model is a better model, or
No. Actually, hidden Markov model is dealing with probabilities.
yes, obviously. I was saying about probabilities of the transition, probabilities of the emission metrics. So ultimately, because I have worked in that
Yes.
particular one. So my question is like, how far it is computationally? How much you suggest? That's what it is. Means we can have other options also for. So,
hidden Markov model I have used for speech recognition. For NLP, I have used a hidden Markov model. By comparatively to other algorithms, that output is comparatively good only. Even I am using hidden Markov model in my research for NLP.
yeah, maybe the hidden states will be the voice, a correct person's voice will be the hidden state, right? In that case, right?
Yes.
And the other parameters will be the other one. Okay.
Yeah.
Yeah, but only from computation point of view, how much it's worth. That's what is my doubt.
For
Compulsory.
for my NLP, I am while using I have got good results only. According to your problem, you have to say whether that algorithm will be good or not.
Yeah, I have also used for like parts of speech tagger, right? So that time when using, so there are nowadays we have other options also. So just to have to cross-check with.
Yeah. You can compare that with unit CNN. You try that also.
Okay, fine. So that is for image. I mean, CNN basically that is for image or for
Yeah. For image.
I have text data.
Okay.
So CNN will be then definitely convolution will be there. So there may be images. There should be images, right?
Yeah.
Yeah, we'll find some other methodology. Just
Yeah,
to,
or you can use for names bias,
okay, sure.
Bayesian networks.
Yeah, okay. Nearby see that.
You check with it.
Thank you. Thank you.
Okay. Any other clarifications? Is there any coordinators from Pencil Bits? Is there?
Yes, ma'am.
Can you ask the participants if there is any queries? They can ask in the chat box or unmute their mic.
Dear Professor, any questions for class? Shall we hand up the class?
Or shall we wind up?
Okay, ma'am. Thank you so much, ma'am. Thank you so much for your wonderful session, ma'am. Thank you.
Okay. Thank you. We will be having our afternoon session at 1:30. We will be dealing with elaboration of supervised algorithms in afternoon session. Thank you. Thank you everyone for your patience in listening my lecture throughout the session. Thank you.
Thank you, ma'am. Dear Professors, I request everyone to join by 1:30 for the afternoon session. Thank you all.